Hello everyone, today we're going to look at usaco-training electric fence. Right, so in this problem, a lattice point is a point which has integer coordinates. So then in this problem, Farmer John has a triangular electric fence starting from the origin 0, 0 to some point nm, and then to some point p0, and then back to 0, 0. So this is basically form a triangle from 0, 0 to nm to p0 and back to 0, 0. So we're just given n, n, and p, and we're going to find the number of lattice points that are inside the fence. So then what I mean is that for example, you would have like some triangles. So it's actually over here. So you have some triangle. So then let's draw some points inside. So you may have this point. So all these would be considered, or all these would like contribute to your answers, since only if they are some kind of lattice point, which means that they have integer coordinates. And a point that is on the boundary does not count. So you cannot like count any lattice point that is on the boundary, but only if it is inside the triangle. So let's get back to the problem. So we're just going to print a single integer that represents the number of counts inside the fence. Alright, so that's it. So what we can do is that we know that our first point is going to be 0, 0. So let's put this, so this is going to be 0, 0. Right, and then our second point is going to be some nm. So we have n, and let's call this nm. And then our third point is going to be some p0. So let's put it over here. So we have p0. So let's connect this. All right, so the first thing that we have to know is that by Pix Theorem, I plus b over 2 minus 1 is going to equal to the it's going to be equal to a. Okay, so I is the number of interior lattice point. B over here is going to be equal to the this is equal to number of lattice point on the boundary. And A over here is the area of your polygon. Okay, so right now in this problem, we're going to try to find what I is. Okay, so we're going to try to find I. So now we just need to find B and A, so we can just use some algebra and deduct what I is. So let's first look at the area. All right, so over here, you know that the area of a triangle is equal to the base times the height. So basically, triangle area of is equal to base times height over 2. So then over here, our base, it will be length on P, because it's a segment from 0, 0 to P0, so the length, or over here, B would be equal to base equal to P, and our height over here, since you have N and M, so then over here, this is going to be N, and over here, this is going to be M. So then, from this, you know that the height is equal to M. So now you know that the area is going to be equal to P times M divided by 2. All right, so now you know the area. So now we need to find out the number of lattice points on the boundary. Okay, so this is a little bit more complicated, but here we go. Okay, so to find the number of lattice points on the boundary, right now we have 3 segments. So over here, if we have something like that, we have one segment like this, and another segment like this, and a third segment like this. All right. So we can basically independently calculate the number of boundary points on each segment. All right. So now what you have is that okay. So now what we need to do is that we're given a line segment. So we have a line segment, and we're going to find how many points are on that line segment. So then, right now, you know that or you can basically piece this into 2 parts, okay? So this is going to be the delta y, and this is going to be the delta x. All right, delta, whoops. It's delta y, and this is delta x. Okay, so first thing we know is that we know that the endpoints are going to be counted. Okay, and then you now that you know this delta y and delta x, your slope, it would be something like delta y over delta x. And if you simplify this, this would become delta y divided by GCD. Let's expand this. GCD delta y delta x divided by, since if you want this in the simplest form, and same thing would go for here, delta y delta x. All right. So for example, if your delta y was like 6 and your delta x was like 4, you would simplify this to 6 divided by 2 over 4 divided by 2, giving you 3 over 2. All right. So let's actually let's first take a look at this case. So we have the delta y is going to be equal to 6. So we have something like this is our top. So 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4. So this is going to be our line. And over here, our focus line is going to be this red thing. Right. So over here, you see that the slope over here, or the GCD over here is equal to 2. So then this means that what we can do here is that we can break this into basically 2 triangles. So then we can break it into 2 portions. So it would be something like from here to here, to here, and from here to here, to here. You know that this is not drawn to scale, but over here the length of this is 2, the length of this is 3, 2, and 3. So then over here you can deduct that at this point this is going to be a lattice point. So it's actually black here. So this would count, and this would also count. All right. So then if you actually go through this, like if you go observe this, whoops, I did not erase that from before, but let's erase this. So let's do that. All right, so over here, you may see that when you take the GCD over here, the result of this is going to be basically the number of triangles you can partition this into. So for example, as you can see, the GCD of delta y equals to 6 and delta x equals to 4 is going to be equal to 2. So it means that you can partition it into 2 triangles. So then basically every point on this triangle is going to be a lattice point. So then, for our line segment here, we're going to add, twice is so small. Okay, so this thing. Okay, so for each line segment, we're going to add GCD, GCD delta y, or delta x and delta y. So then over here we're going to get 2. All right. But over here we're not actually going to add an extra one. We're not going to do this because if you actually consider the whole polygon or the whole triangle over here. So let's just say we have this triangle. Okay, so right now, let's just say we found that we can parse in, or we found, let's just draw the lattice point. So here, let's just say we have, we know that these are, let's just say we have one here, and we have 2 here, and let's just say we have nothing here, okay? So then over here, the GCD of this line is going to be equal to 3. The GCD of this line is going to be equal to 1, and the GCD of this line is going to be equal to 2. All right, so over here we know that the total number of lattice points is going to be equal to 1, 2, 3, 4, 5, 6, and the sum of this is exactly 6, which is what we want. Okay, so why aren't we adding this +1 at the end? Because the thing is that if we add the +1, let's take a look at this point. Okay, so if you add the +1, then this line and this line would include this point. So then basically this point would get double counted. So then either you can basically add this +1 and at the end you just -3 since you know that you're overcounting each point twice. Twice. Or you can just not add this +1 and just find the GCD. All right, so now we also know how to find B over here. All right, so now the last thing we need to do is to basically simplify this equation so we can find I. Right. So over here again, let's take a look at this. So we have I plus B over 2 minus 1 is equal to A. So let's just move these 2 over there. So we have I equals to A minus B over 2 minus 1. All right, so that's this is plus. So then we know this is equal to what is it? PM over 2 minus B over 2 plus 1. So then here we can just do PM minus B over 2 plus 1. So that's it. So and over for B, we know that we can find it based on finding the GCD, and that's going to be it. So let's get coding. All right, so here we have let's get my template. All right, so we can have a point. It's going to be integers. So we're going to have, let's just give a long since just to be safe. All right, so we're going to have 3 integers. Oh, actually, we don't need long. All right. So we have N, M, and P. So let's read that. All right, so we know that we have 3 points. So our first point, so if 0 will be equal to 0 and 0, our second point would be equal to NM. Our third point be equal to P0. Alright. So now remember what we have is that our answer is equal to P times M minus B divided by 2 plus 1. Alright, so let's first find B. So first thing we're going to do is find B. So then for each of those three segments, we're going to have delta y equal to absolute value of a I plus 1 dot y. Or let's actually use this. Or we can have just j equals to I plus 1 log 3. Alright, so over here this would be aj dot y minus ai dot y. And our dx would be equal to absolute value of aj dot x minus ai dot x. So then, let's have our b. We're going to add the GCD of dx and dy into our RB. Okay, so now we found b, and we know what p and m is. So now our answer is just going to equal to p times m minus b divided by 2 plus 1. So let's just print out our answer. So let's try that. Oops, other. Alright, so fence 9, 7, 5, 10. Alright. 20, correct. So let's submit that. Free open fence 9.in. Free open fence 9.out. Alright, STL. Alright, so okay, problem fence 9 language C++ solving. Alright, so let's go over here, submit it. Alright, so YouTube, what's that? Alright, fence 9. Fence 9, alright, got it. Submit. Oh yeah, I forgot. Alright, so over here, I'm compiling with C++ 17, but the training server only supports C++ 11, so the functions are a bit different. We just need to add these double two ticks or double two underscores over here. All right. Yeah, okay, so that's fine. Okay, so everything is correct. So that's it for today. If you have any questions, feel free to leave them in the comment section below. Bye.